Hello, this is Brian Ngo, and I am doing a presentation on this journal called Creating False Memories, Remembering Words Not Presented in Lists by Roediger and McDermott. This is in regards to Experiment 1 and its background. This experiment focuses on false memories, which are either remembering events that never happened or remembering them quite differently from the way they happened. Interest in this is due to increases in number of cases in which memories of previously unrecognized abuse are reported during the course of therapy. Works of Bartlett is usually credited, and his results seem to show distortions in subjects' memories over repeated attempts to recall. He also distinguishes between reproductive and reconstructive memory, which is reproductive is the accurate but not production of material from memory, and reconstructive is the emphasis of the active process of filling in missing elements while remembering. However, there are errors frequently occurring through this process. The purpose of this study is to replicate previous works by Deese and his observations of false recall by using 6 lists that produced high levels of erroneous recall. He was also interested in predicting the occurrence of extra list intrusions in single trial free recall, and also focused on his own paradigm in regards to it. The goal within the study is to replicate and examine false recall and false recognition of critical non-represented words and the confidence with which subjects accepted or rejected the critical and non-represented words. For the Experiment 1 methods, subjects included 36 Rice University undergraduates who participated as part of a course project. For the materials, they developed 6 lists, and they followed the materials listed in Deese's article. They chose 6 targets with high intrusion rates within the list as well, which included words such as chair, mountain, needle, rough, sleep, and sweet. There was also a 42-item recognition test afterwards of the 6 lists provided, in which there were 12 studied items and 30 non-studied items within the recognition test. For Experiment 1 procedure, subjects were tested in groups during regular class meeting and instructed that they would hear lists of words and that they would be tested immediately after each list by writing the words down. They were told to write the last few items first and then to recall the rest of the words in any order. They were also told not to guess to ensure confidence in what they believed in. The lists were read aloud by the first author at a rate of one word per 1.5 seconds. After the 6th list presented, subjects were told that they would receive another test. They would see words on a sheet and then that they were to rate each as to their own confidence of if they were present, based on a 4-point rating scale. 4, sure the item was old, 3, probably old, 2, probably new, and 1, sure it was new. Subjects were asked to raise their hands if they recognized 6 items on the test, and critical words were read aloud. Most of the participants raised their hands for several items. However, they were also informed none of the words said were not on the list. And they were also debriefed about the purpose of the experiment. This is for experiment run results. Shows the serial position curve and the output quintile curve. Curve was smoothed through averaging data. Mean probability of recall of studied words was 0.65, and it shows a strong primacy event, probably due to strong associates of the critical target words occurred earlier in the list. Also, critical omitted words were recalled with a probability of 0.4. And the serial position curve shows marked recency indicating subjects follow directions in recalling the last items. Also, the average output position for the output quintile curve, the recall of the critical non-represented word was 6.9 out of 8.6 words written down. For the results of the recognition test, the recognition test was given the following study and recall of all 6 lists. Results were likely affected by prior recall. The rate of false alarms was higher for the weakly related lures based on the data, and the false recognition rate for weakly related lures was greater than obtained in many prior studies, and the rate for the critical non-represented words was dramatically larger than the rate for the weakly related words. For experiment 1 discussion, it confirmed Deese's observations high levels of false recall. It found that the critical non-represented words were recalled at about the same level as items actually presented in the middle of the list. The false alarm rate for the critical non-represented items approximated the hit rate for the studied items. More than half the time, subjects reported that they were sure that the critical non-studied items had appeared on the list, and that they were sure. Experiment 2 is planning on improving on the previous experiments, i.e. experiment 1, and they're doing this through developing 15 item lists similar to previous lists used in experiment 1, and this is also due to the previous experiment where they obtained a high level of false recognition for the critical non-represented words, but the list had been recalled prior to the recognition test, and in 40% of the cases the critical item had been falsely recalled. So the 4 aims in regards to experiment 2 is to 1, they want to replicate and extend the recall and recognition results of previous experiments. 2, examine false recognition both for lists that had been recalled and for those that had not been recalled. 3, wanted to determine the false alarm rates for the critical non-represented items when the relevant list had not been presented previously. And 4, conducting the second experiment was to obtain subjects' judgments about their phenomenological experience while recognizing non-represented items. In regards to experiment 2 methods, subjects included 30 Rice University undergraduates who participated in a 1-hour session, and with the materials included were a developed 24 list from Russell and Jenkins, and for every 8 lists provided were followed by an immediate free recall test, while 8 others were not followed by an initial test. They were also given a recognition test. The design included 3 conditions which were being tested. Subjects studied 12 lists, and items from all 24 lists appeared on the later recognition test. That is all 1. On the recognition test, subjects judged items as they remembered the item from the list, or rather knew that it happened, and they judged it as either old or new. It also included 96 items, 48 studied within it, and 48 not, as the test in memory. For the procedure within experiment 2, subjects were told that they would be participating in a memory experiment. They were also told that after each list they would hear a sound, either a tone or a knock. For half of the subjects, the tone indicated that they should recall the list, and the knock meant that they should perform math problems. For the other half of the subjects, the idea was reversed. They were also told to listen carefully to the tone and list, and in addition, they were instructed to note judgments immediately after judging the item to be old before they considered the next test item. The recognition test also occurred about 5 minutes after the test. For the experiment 2 results in regards to recall, subjects recalled the critical non-represented word on 55% of the lists, and due to this recalled at a higher rate than the 6 lists used in experiment 1. The higher rate of false recall may have been due to the longer lists in experiment 2. They also smoothed the serial position within the graph, and it shows a primacy and recency effects within the graph. Recall of the critical missing word was actually greater than recall for studied words in the middle of the list provided, with T29 equals 1.8, SEM equals 0.042, P equals 0.08, and it was a two-tailed test. For the experiment 2 results in regards to recognition, based on the data, 0.79 was greater than the study. And there was a boost in recognition from prior recall and was reflected in a greater proportion of remembered responses. Also, after subjects had heard all 16 lists, they received the recognition test and provided remember no judgments for items that were called old on the test. They also first considered results for studied words and then turned to the data for the critical non-represented LERRs. The stats also indicate that the act of recall enhanced later recognition. Also, results for false alarm rates appear practically identical to the results for hit rates. In regards to conclusions, in experiment 1, with 12-word lists, subjects recalled the critical non-studied word after 40% of the lists. In experiment 2, with 15-word lists, false recall increased, occurring on 55% of the occasions within the experiment. This paradigm from the experiment also produced remarkably high levels of false recognition for the critical items. False recognition responses were frequently made with high confidence or were frequently accompanied by remembered judgments. The act of recall increased within experiment 2 due to both accurate recognition of studied items and the false recognition of the critical non-studied items. Limitations for this experiment were results did not have any direct bearing on controversies over false memories induced in therapy, and since experiments occurred in a laboratory setting, holds questionable relevance to issues surrounding more occurrences outside of lab. And here are the references used in the article and in the presentation.